Last but not least, we cannot talk about probability without talking about sample space. Sample space is one of the most important concepts in probability. And what the sample space tells you is the total number of outcomes that are possible in a particular event. So in the previous videos in this series, we've talked about what happens if you roll one die and there are 6 total outcomes. But most of the time when people play with dice, there's 2 of them. So here you have a sample space chart that tells us all of the combinations of numbers that could happen, or all of the possible outcomes that can happen if we roll a pair of dice. So let me explain this chart to you. So here we have the first die, okay? And as you can see, you have 1, 2, 3, 4, 5, and 6 are the different options that first die will land on. Across the top, we have the second die. 1, 2, 3, 4, 5, and 6 are the different numbers that are on that second die. In this table, it looks like ordered pairs. We strategically wrote them as ordered pairs because that is what's going to happen when you roll the pair of dice. You have examples such as the first die lands on 3 and the second die lands on 2. You have another example down here. The first die lands on 4, the second die lands on 5. In this case, the first die lands on 1, the second die lands on 4. In this case, the first die lands on 6, the second die lands on 3. So, if we look at this, the total number of outcomes in our sample space is 36. And we can kind of shorthand it. We have 6 options in the first one, 6 options in the second die. 6 times 6 gives us 36. Now, how do we bring all this together? Let's say we want to find out the probability of rolling a pair of dice and getting a sum that is greater than or equal to 8. So, okay, so I want to find out the probability of rolling a pair of dice and the numbers that they land on is a sum greater than or equal to 8. Well, all I have to do is go through my sample space and figure out how many number pairs are greater than or equal to 8. Now, we know that the total number in the sample space is 36. So our denominator is taken care of. So let's go through and find out how many of these number pairs have a sum greater than or equal to 8. Well, there's 1, there's 2, 3, 4, 5, all right, so we have marked all of them, I believe. And let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 number pairs that are greater than or equal to 8. Now, so the probability of rolling a pair of dice and getting a sum greater than or equal to 8, which is going to be 15 over 36. And actually, we can divide both of those numbers by 3. So 15 divided by 3 is 5. 36 divided by 3 is 12. So the probability of rolling a pair of dice and the numbers that those dice land on is a sum greater than or equal to 8 is going to be 5 out of 12. We can pick many different scenarios to figure out what to do in regards to this sample space. I'll give you one more example. Let's say we want to find out the probability of a sum less than 8. Okay, let's find out a sum less than 8 in this case. All right, now, so we need to figure out how many of these number pairs have a sum less than 8. Well, and actually in this case, this is technically going to be the complement of the previous scenario that we had. So, ironically, in order to do this, we can, as you see, we counted out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 number pairs that have a sum less than 8. Okay? So, this is going to be 21 out of 36. But since it's the complement, because everything else that's not greater than or equal to 8, we can actually simply say 1 minus 5 over 12. Okay? And 1 minus 5 over 12 is going to be 7 over 12. Okay? Once again, there's different scenarios that you can put to this sample space, but this is the combination of all the different number combinations that you will get when you roll a pair of dice. Young Guru's Math Tutoring, the solution to your math problems.